Hello, myself Dr. Kalyani, working as Associate Professor in the Department of Computer Science and Engineering of Institute of Aeronautical Engineering. In this video, I will discuss regarding software design process. So, this topic learning outcome is mapped with the course outcomes of CO4, which is understand the importance and need of design and explain the various approaches of designs. What is software design? Is the mechanism to transform user requirements into some suitable form. The requirements are gathered with a variety of techniques like interviewing the customer, keeping survey forms or questionnaires, on-site observation. By using these techniques, the requirements are collected and these can be converted into visual modeling with the help of software design. So, the design helps the programmer in software coding and implementation so that the software engineer can easily convert these design diagrams into respective programming language. It deals with representing client's requirement. All the client's requirements are documented in SRS, Software Requirement Specification Document, and by using this that can be converted into implementation form with the help of software design model. In software design, the system is considered to be a set of components or modules with clearly defined behavior and boundaries. Generally, there are two levels of software design. One is external design, second one is internal design. The external design focusing on which the user aspects are the interactions with the outside boundaries or the stakeholders. So the modules are needed their specifications so that the interfaces how they are to be realized with the help of interactions. So the stakeholder can easily access through these interactions the software functionalities or modules. The second one is internal design. It focusing on planning and specifying the internal structure and processing details. So the architectural and component level design is more majorly focused in the internal design. The major objectives of software design are generally the correctness, completeness, efficiency, flexibility, consistency, maintainability. So, if these features are in the software design, so that the scalability and efficiency of the application as well as the performance and security of the application can be greatly increased. The phases of software design generally, the interface design, architectural design and detailed design. Interface design is majorly focused on specification of the interaction between the system to its environment. So, apart from the boundaries of the system, how internal and external stakeholders are communicated is majorly focused in the interface design. These interactions can be generally implemented with application program interfaces. So, this phase proceeds at a high level abstraction with respect to the inner workings of the system. So, the design problem statement produced during the problem analysis step should identify the people, the other systems, devices which are collectively called the agents. So, the stakeholders are clearly identified and each functionality of the system, how they are interacted with this external environment is clearly defined with the help of interface design. Generally, the use case diagrams are more helpful in case of interface design. And the modules how they are interacting with is also closely related and realized with the help of interfaces. So the component diagram also greatly useful in case of the interface design. But what are the interface design issues? Precise description of events in the environment or messages from agents to which the system must respond. So the sequence of activities, those are carried out during transaction processing of the system, are majorly emphasized in case of interface design, and so that the interactions are clearly between objects and agents are clearly modeled with the help of message passing technique. So precise description of the events are messages that the system must produce, and specification of the data and the formats of the data coming and going out of the system. So the input format as well as output formats are concentrated. Specification of ordering and timing, relationships between incoming events or messages and outgoing events are outputs. If the garbage is given as input, then you can get the garbage as output. Based on the GIGO principle, you must clearly define the correct input so that the accurate output can be produced. So these issues are concentrated in case of interface design. The next variety of design is the architectural design. In case of architectural design, the specification of the major components of a system, their responsibilities, properties, interfaces, and the relationships and interactions between them is modeled with the help of architectural design. So generally, the deployment diagram of UML are greatly helpful for the architectural design. In architectural design, the overall structure of the system is presented, but the internal details of major components are ignored. The architectural design issues are gross decomposition of the system into major components. So the functional independence and process decomposition is concentrated, and allocation of functional responsibilities to components, component interfaces, component scaling and performance properties, resource consumption properties, reliability properties, as well as the communication and interaction between the components are greatly concentrated in case of architectural design issues. So what are the static elements present in the project and how they are interacting is majorly focused in case of architectural design issues. The next level of design is detailed design. So design is the specification of internal elements of all major system components, their properties, relationships, processing, algorithms and data structures are focused in case of detailed design. So the top level design is produced by the user interactions are produced by the interface design, and the high level design is produced by the architectural design. So the components are identified, how they are related are produced with the help of the structural or architectural diagrams. But the detailed design clearly describes the implementation details and the data and algorithms based on which the architectural elements are communicated is emphasized with the detailed design. In detailed design, Each module is examined carefully so to design the data structure and the algorithms. So this space outcome is documented in the form of a module specification document. So the output of this detailed design is a module specification document. So the general issues that are focused in case of detailed design are decomposition of major system components into program units and allocation of functional responsibilities to the units. How the user interfaces are implemented. What are the unit states and state changes? So how events are received so that the application state transition can be performed. So the data and control interaction between the units and data packaging implementation, including issues of scope and visibility of program elements. Algorithms and data structures are greatly focused in the detailed design. These are the major means of implementation of low-level design. The design process is majorly concentrated on generation of a model which shows firmness, delight and commodity. So software design process is an iterative process through which requirements are translated into blueprint for building the software. So from the analysis phase of the software design project programming accept the requirements from the clients are collected and requirement engineering process are applied on these collected requirements and the validated requirements are documented in the SRS. So the output from this phase is the software requirement specification. These requirements can be by using the software design process with the help of various case tools and UML diagrams. These requirements are converted into software design document. So this conversion is performed in the design process. So what are the various principles applied during this design process? We will discuss in this video. So what are the software quality guidelines? A design is generated using the recognizable architectural styles and compose a good design characteristics of components and it is implemented in evolutionary manner for testing. So a design of a software must be modular and logically they are partitioning the components or the modules of the software. In the design, the representation of data, architecture, interface and components should be distinct. So a design must carry appropriate data structure and recognizable data patterns. The quality guidelines that are followed in the designing process are: design components must show independent functional characteristics. So the distinct features or the functionalities are modeled in the software project. A design creates an interface that reduces the complexity of connections between the components. So between stakeholder and the functionality, how these stakeholders can access the functionality through interfaces is designed and is concentrated in the design. It is the one of the software quality guideline. A design must be derived using the repeatable method. The notation should be used in design which can effectively communicate its meaning. Notations are standard notations used in the design so that each user can easily understand the functionality interactions of the software design. So what are the quality attributes that are used to evaluate generally the design process? One is the functionality. Next, usability, reliability, performance, supportability, testability. So what is the functionality? It evaluates the feature set and capability of the program. So what are the gathered requirements that are documented in the SRS and verification that against its implementation. Next, usability is accessed by considering the factors such as human factor, overall aesthetics, consistency, and documentation. So the look and feel features, cosmetic features, and how easily the user can access the application is evaluated using the usability. Reliability is evaluated by measuring parameters like frequency and security of failure and the output result accuracy, the mean time to failure MTTF, recovery from failure, and the program predictability. So the time duration, how the project can withstand against failures is evaluated with the reliability by using the parameters like MTTF, MTBF, mean time between failures, and MTTR, mean time to repair. The next quality attribute of the software design is performance. It is measured by considering processing speed, response time, resource consumption, throughput, and efficiency. Supportability is another quality attribute. It combines the ability to extend the program, adaptability, serviceability. These three terms defines the maintainability. So, the program adaptability, serviceability must be used in order to test the compatibility with the various browsers and operating systems. So, which in turn linked with the testability, compatibility and configurability are the terms used in the system to evaluate the testability and install and found the problems easily when the project is deployed on the client side. So the software design concepts generally are the abstraction, information hiding, refactoring, modularity, design patterns and refinement, architecture and refinement. What is abstraction? A solution is stated in large terms using the language of the problem environment at the highest level of abstraction. So, giving only the necessary details by hiding how to implement them or the lower level design details is generally referred as abstraction. The lower level of abstraction generally provides more detailed description of the solution. So, a abstraction can be data abstraction or procedural abstraction. A sequence of instruction that contain specific and limited function is referred as procedural abstraction. But collection of data that describes data object is the data abstraction. So, two types of abstractions are available. One is procedural abstraction, second one is data abstraction. Data abstraction is regarding collection of data regarding one particular objective. So, here in this example, we consider the object as door and collecting some data regarding that door. It is modeled as data abstraction. But in case of procedural abstraction, by using this data, how the functionality is implemented or the knowledge that is provided is generally considered as procedural abstraction. So here the door here the functionality is open. So how to perform this functionality is clearly stated in case of procedural abstraction. The next design process term is architecture. So the architecture generally presents complete structure of the software, and the architecture is structure of program modules where they interact with each other in a specialized way. So the aim in the software design is to obtain an architectural framework for a system. Generally, the types of architectures are structural models, framework models, dynamic models, procedural models, and functional models. So, the structural models is one type of architecture which represents the architecture as organized collection of program components. But framework model increase the level of design abstraction by attempting to identify repeatable architectural design frameworks that are encountered in similar types of application. The next variety of architecture is dynamic model, addresses the behavioral aspects of program architecture, indicating how the structure and system configuration may change as a function of external event or stimuli. Next variety of architecture is procedural architecture. So these models focus on design of business and technical processes that the system must accommodate. Last variety of architecture is functional model, which is used to represent the functional hierarchy of a system. The next term in the design process is design patterns. A design pattern describes a design structure. That structure solves a particular design problem in the specific context. So here each design pattern is to provide description that a designer to determine whether this pattern is applicable to the current work or the problem stated in the SRS, whether the pattern can be reusable, so reusability is concentrated, whether the pattern can serve as a guide for developing similar but functionally structurally different pattern. So reusability is greatly concentrated in the design patterns, identifying of correct pattern and focusing on the reusability of the specified patterns. Next term is modularity. So based on separation of concern, the project can be divided into small manageable units, generally called the modules. So a software is separately divided into name and addressable components. So sometimes they are called modules which integrate to satisfy problem requirements. Modularity is the single attribute of the software that permits a program to be managed easily. So the number of modules in the program is greatly affect the performance of the application. So this decision is the important factor in the software design. Next term is information hiding. Modules must be specified and designed so that the information like algorithm, data presented in a module is not accessible for other modules not requiring that information. So, access specifiers are greatly helpful for information hiding so that the only required details are shared with the other modules by keeping or preserving the important details privately by the modules. So, hiding implies that effective modularity can be achieved by defining a set of independent modules that communicate with one another only that information necessary to achieve the software function. The advantage of information hiding is it reduces the likelihood of side effects. So, unnecessarily the data should not be shared with other modules. It greatly reduces the undesired side effects in the functionality or misfunctionality, limits the global impact of logical design decisions, emphasizes communication through controlled interfaces, discourages the use of global data, leads to encapsulation, an attribute of high quality design, results in high quality software. Next term is functional independence. The functional independence is the concept of separation and related to the concept of modularity, abstraction and information hiding. So, independent modules are easier to maintain because secondary side effects caused by design and code modifications are limited or prevented. Error propagation is reduced. So, the functional independence is accessed using two criteria that are the cohesion and coupling. What is cohesion? Cohesion is an extension of information hiding concept. So, a cohesive module performs a single task and it requires a small interaction with other components in other parts of the program. So, basically, cohesion is the internal glue that keeps the modules together. To acquire one simple functionality, what modules are glued together is decided with the cohesion. So, in a good software design, the high cohesion must be required. The single-mindedness of achieving a functionality is generally referred as the cohesion. The next term is the coupling. It is an indication of interconnection between modules in a structure of a software. Good software will have low coupling, and types of coupling are data coupling, stamp coupling, control coupling, common coupling, and content coupling. The next term in the software design process is refinement. Refinement is a top-down design approach, and this is a process of elaboration. So, a program is established for refining levels of procedural details. So, a hierarchy is established by decomposing a statement of function in a stepwise manner till the programming language statements are reached. The next term is refactoring. So, it is recognition techniques which simplifies the design of the components so that the components can be reorganized without changing its functional behavior. Refactoring is the process of changing the software system in a way that it does not change the external behavior of the code, still improves its internal structure. The last term that can be discussed in the design process is the design classes. So, it is the model of software that defines set of design classes. So, each and every class describes the elements of problem domain that focus on features of the problems which are user visible. So, the general characteristics of design classes are complete and sufficient, primitiveness, high cohesion, low coupling. So, a design class should be the complete encapsulation of all attributes and methods that can reasonably be expected to exist for the class. The second characteristic is primitiveness. Methods associated with a design class should be focused on accomplishing one service for the class. so that the clear functionality must be produced or the service must be provided to the user. High cohesion, a cohesive design class focused set of responsibilities and single-mindedly applies attributes and methods to implement those responsibilities. So, a good software design focused on high cohesion. Low coupling, design classes to collaborate with one another. They should keep an acceptable minimum dependencies in the collaboration. So in this video, I discussed regarding what is the software design, what are various levels of software design, and in the design process, we discussed the basic terms like abstraction, design classes, refinement, modularity, etc. And the references used in this video are this. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.